Now we're actually going to be working one of these types of problems, and hopefully you'll get a good idea of what we're doing. So this is going to be your key aspect of it, is filling in this chart here and getting these filled in as much as possible, and then we can approach our final answers. So we have 8.6% ethanol by mass. And again, we're assuming that nonane, that gasoline's a pure substance, but it'll work for us. All right, if we're given percent, do you remember what our assumption was? What you want to do if you're given percent is assume 100 grams. Remember, it's percent by mass. So we want to assume that we have 100 grams of solution. Now, if it's 8.6%, that means we have 8.6 grams of solute. And if we do our subtraction, that means we would calculate this to be 91.4 grams for our solvent. And that gives us some direction here. Now, one of the questions it asks is what is the mole fraction? And then the other is what is the molality? So we need the mole fraction of ethanol, which means we need the moles of ethanol. We need the moles of ethanol and the moles of nonane in the denominator. Now, to get the molality, what we need is moles of ethanol over kilograms. Remember, just the solvent. Well, we already have part of that. By doing it this way, we now see that we have kilograms of solvent in our chart, 0.914. So we have to get to moles. We have mass of solute, we can get to moles of solute. We now have mass of solvent, we can get to moles of solvent. So I have 91.4 grams of nonane, C9H20. Remember, it's CnH2n plus 2 to get to our anes, our saturated alkanes, 128.29 grams for 1 mole, and that gives me 0.7124 moles. So right now I'm going to put that up here. So 0.7124. So that could be a handy piece of information. And the other is 8.6 grams of ethanol, C2H5OH. We've seen this before. You'll often be given molar masses anyway. 46.08 grams, 0.1866. So assuming I did all my calculations correctly, you now have everything you need. And it's in your table. We didn't use this. We won't often use those. And we can't use this. You can't have moles of a mixture. And the only time we're going to need volume of solution is if we're asked about molarity, which we aren't asked about, nor are we given our density, so we can't fill that in. But at this point, you have enough on your problem-solving grid to go ahead and plug in. So we have our moles here, 0.1866. Can't read my own handwriting, 0.1866. And that's actually for both of those, and then 0.7124. And I think if you do that, you'll see, if you just start filling in these grids, for one thing, you'll get some partial credit for doing that. And for another thing, when you have problem-solving grids, the goal is to get your mind moving. And approaches like this often kickstart your mind into the right direction. So what we had, our final results were that our molality, if you carried through those calculations, was 2.0 molal, and our mole fraction of ethanol was equal to 0.21. All right, let's try another one of these, and this time we're going to include in that calculation molarity. So let's move on to the next problem. So we're again talking about that HF. Don't forget, AP thinks you're going to pick this up in the conversation, so I'll bring it up a lot. HF etches glass, which is SiO2, which is also sand. They're all related to one another. So in this case, we have a 49% aqueous solution. So we have the similar type of assumption as we had in the last one. Our solution is going to be 100 grams, which means that 49% of those grams are HF, and 51% of those are our solvent, which in this case, since it's aqueous, our solvent is water. Now, it asks us this time to calculate 3 different concentration units: the mole fraction of HF, we need the molality of HF, and we need the molarity of HF. So let's start seeing where we can fill in on our grid. Not going to need this. We're not going to need these time because we're not given densities, but we are given the density of the solution. And the density of our solution is 1.175 grams, equal to 1 milliliter. So that's what we're going to get to use to convert for there. I wanted to set that up as an equality so you can see that clear as our conversion factor there. So let's just jump into this and fill in as much as we can. If I have 100 grams of my solution, be very careful because the density was of the solution, so I have to take the mass of the solution, not the mass of the solvent. 1 milliliter, 1.175 grams. And what I'm going to end up with for this is 0.0851. I've actually already converted that to liters. 0.0851. So you needed an extra step in here that I didn't show. And now we want to go mass to moles for water. Mass to moles use molar mass. I have 51 grams of water times 1 mole per 18.02 grams. I bet you have that memorized by the end of this year. We'll use it quite a bit. And so our moles of water end up being 2.83. So we have 2.83 moles of water. And if we did a similar calculation for HF, I'm going to assume that you know how to do this. The number I got is 2.45. If indeed I make any math mistakes, you can be sure to tell me about that. So we've got the grid filled out. Now we can start taking a look at actually doing some of the required mathematics. So the mole fraction of HF is going to be the moles of HF, 2.45, over the total moles, 2.45 plus 2.83. And I get 0.4640. We're going to call that 0.46 because I only have 2 significant figures in that original percentage. And for the molality of HF, we need 2.45 moles of the HF, and we need kilograms of solvent. So all I need to do is convert that to kilograms, but that information is clearly laid out on the table for us. And I get a very high molality, 48 molal. I mean, this is what you're purchasing in a store typically for HF, and it's going to be very, 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 very concentrated and dangerous, by the way. Now to get my molarity, I need those same 2.45 moles. And this time I need liters of solution, and we were able to calculate that because we were given the density of the solution. So, and I get 29 molar solution for these. So those are our 3 answers. So I hope you see that calculating with this table and then laying out the formulas very explicitly of what you need, these problems should actually be much easier than they appear to be on the surface.